Okay, so that's what we'd like to do now, this bubble sorting. Again, as I said, the bubble sorting, what it does, it's sorting the array, same idea, by trying to find the maximum, putting it on the right side, but this time by looking at each two element, if two elements consecutive to each other, and try to make sure that these two are in the right order. The one on the left is smaller than the one on the right. And what if it's not the case? Let's run and stop. Now this is, for example, the one on the left is smaller than the one on the right, so I'm not going to do anything. But in this case, this one on the left is not smaller than the one on the right, so I'm going to swap them. And in order to swap them, of course, I need a temp variable, because every time you would like to swap two variables, you need a third one so you can preserve the two. So now again, I'm going to swap here and swap a couple of times until I reach this one. Let me just run it so you can see I'm swapping again, and I'm again swapping, except when I'm reaching here, I'm not swapping because I don't need to. Then here, I need to, and so on. So now, that's what I'm going to do. So what I'm doing, I'm just going to do the same thing, except that instead of I will start again with the int, so it will be much easier. Then we'll generate that to anything we want. So let's just go back with an int. So I'm just going to make this an int. I don't want to generate an array of students, but generate an array that is going to be of int. Let me just copy this. I'm going to create a new one. We just generate random array with the size. This time it's going to be about an int, and new. I'm just going to take the same random thing that we're using and return that array. Of course, I need to have also int here. Oops, int, I meant. So I'm generating an array that is randomly having numbers between 1 and 100, and then I'm going to display the array by just making sure it's just an int. Oh, you know what, let's leave this one and copy another one and copy and paste, and with int. Now, so I'm overloading this because when it's an int, I would like to display and stay on the line. When it's an object, I'm just going to, I don't need to go back to the line afterwards. If it's an object, I'm going to keep it like that. Then let's go back here. Now the selection sort is not what I'm going to use. I'd like to use this. I'm going to create something that is going to be bubble sort. And the bubble sort, I'm going to give it that array, and then it's going to sort it, and then later on I'm going to display it again. So just push this down. I'm going to create a new one, private static void bubble sort. So it takes an array of int, and it's going just to do something with that array. So what do we need to do? If we would like to do something similar to this, what shall we do? The first thing, I'm sorry? Declare max. Do I need to have max? I just need temp. I don't need really a max, but let's say, okay, I'm going to follow, and I'm going to declare max and temp. Okay. Then I need a for loop, definitively. Let's start from 0 until array.length. And come on, we're recording a video. Don't, yeah. First start with the loop. Without this, okay, and inside, okay, it doesn't make a big deal, but all right. Now I need to compare. What I'm doing here, I just need to compare two of them, right? Now the first time, let's just start again. The first thing that I do is that I compare the first element with the second element, right? So let's do that. Let's forget about this. We declare when we need them. How can I compare? If what? Array 0 less than array of 1 well, we need to put an I, but now let's just put something at least for this first one, and then we try to generalize that. So if the way this one is smaller than this one, we need to do something. You want to say something?
Instead of array 0, array I, and then the other one array I plus 1.
Okay, that's what maybe you were looking for. Now, can I do array I and I plus 1? Because the first time I is 0, so I'm going to be, array I is going to be this one. Array I plus 1 is going to be the next one. And then when I becomes 1, this is going to be here. And then plus 1 is going to be here. So I'm going to compare these two. And this for loop now with this if is going to compare the first with the next to it, the second with the next to it, the third with the next to it, and so on. But there's a problem. What is the last value of I? Now, every time we do something like this plus inside these brackets, you have to be very careful of the last number that is going to be, of the first and last number. Now, if I put this I plus 1, which means my last value, let's say my array.length is equal to 5, just to make things simple. The last value is going to be 4. When I is 4, 4 plus 1 becomes 5. Do I have array of 5 when the size is 5? No, I don't. So you have to be careful. When you do these pluses, these operations between the brackets, make sure that your values are going to be not getting out of the different acceptable indices. So what should I do now? Just to make this, because I'm accommodating here, the last value should be, so I need to go back by 1. Why? Because I'm going to start from here until here. For each one of them, I'm going to check that one and the one after it. So that's why I need to stop here, not here. Because if for this one until this one, when I'm reaching the last one, I'm going to check this one with the next to it, which is fine. But if I'm including this one too, I'm going to reach this one and ask for the next to it. But there's no next to it. So that's why I had to make this array.length minus 1. So we're getting somewhere. Now we're almost there. We said that what happens when this one on the left is, not this case, I'm just going to take something like this. When this one is smaller than this one, the first one, is smaller than the one next to it. Should we do something? When it's smaller, we don't do anything. We do something when it's kind of the opposite. When this one is bigger than the other one, then we need to swap. So when this first one is bigger, then I need to do something. If it's not, then I need to do anything. Just keep moving. Go to the next one. And now, to swap, I just need to have this temp that I'm looking for, and just need to use array.I. One of them is going to be here, and array I, I'm going to put inside of it array I plus 1, and whatever was in the temp, I'm going to put it into that. Notice one thing, when I'm doing the swap, this is what always happens. This variable that I'm saving into the temp is this variable that I'm updating. So I'll take this value, save it, then change it. Change it with this value, okay, then this value now is going to be, this variable is going to be changed. So as you can see, there's always this one, if it's on the right side, on the next statement it will be on the left side. And whatever is on the right side, in the next statement it will be on the left side. So that's how this thing works. If I'm swapping between A and B, this is A, and this is A, and this is B. Imagine that these are two variables. So whatever it's in A is going to be in the temp, so B is going to be saved into the A, and then the temp is going to be inside the B. I don't know, maybe I made it even more complicated. But the idea is, there's always this pattern. If I start by saving I plus 1, I will do this I plus 1 first, and then put this I here in there. That's what I'm trying to say. It doesn't matter with which you start, but if you start with 1, saving it into the temp, that's the same one that you're going to change. But if you mix up this with that, then it's going to be completely not what you want. So that's what I'm trying to say. So doing it this way or that way, that's the same. So now I'm swapping them only when I find like that this one on the left is bigger than the one on the right. So this is the one on the left, and the one next to it, the one on the right, is this one. So if the one on the left is bigger, then swap them, and then we keep going. So once I finish this loop, I just would like to be able to display and see what is going to be the result. Let's try that. Now what I did is that, notice that 91 now has been pushed here. So it just tried to find this one. Is it bigger than this one? No. Move on. This one bigger than this one? Yes. So it's moved 21 to be instead of this. And then now 91 is here. Is 91 bigger than 48? Yes. So it swapped them again. And it kept swapping 91, then it pushed it to the right until it went to the last part. Now I just found the last, like the maximum, I'm going to put it on the right side. I need to do the same this time with this thing. So what I'm going to do, first of all, I'm just going to do the same again. So you can see the loop. I'm just going to copy and paste. Now, if I'd like to do the same until this one, not including the last one, I should just, this instead of -1 should be -2. And that's it. That's all I had to do. Now I can have the last two elements to be on the back. Why? Because I'm doing exactly the same thing, but except I'm checking all the values, I'm just checking up to this one. And I'm going to repeat again. What if I'd like to add the other number? It's going to be -3. And you're going to see it, yes, that's of course I should put an I there, because now as you can see it just gets the bigger 3 now into the end. Now how can I put the I? Okay. Now if I'd like to put like some kind of not this going to be inside of another loop. So I'm going to surround that with the for loop. Of course I cannot, both of them have been to be I. I'm just going to name it, well, keep this as I, and then this one I'm going to make it J. Because it's, I don't know, it's, or maybe keep this as I and name this J. So now, what should I do? First of all, J is going to be from 0 to what? When should I stop? I mean, I'm going to do this until it is equal to, so I need to be, in other words, if this is my array is out of 5, okay, this should be 4. If my array, the size of my array is 5, this is going to be 4, right? And next time it will be 3. Next time it will be 2. And what should I stop?
Stop when it's 0.
When it's 0? No. Okay. So if I do something like this, if my array was out of 5, if I do something like this, let me just maybe take this out. And this is my array. We said out of 5. I'm just going to make an array of 5. And let's try that. If my array out of 5, now this is sorted, right? All of them. Because I have 1, 2, 3, 4. Why 4? Because I'm just comparing. Okay, hold on. This is too much. If I have these variables, now this is my array. How many comparisons do I need to do? I need to compare this one with this one, then this one with that one, this one with this one, and that one. So how many times? 1, 2, 3, 4. So how many times I need to repeat the whole thing? 4 times. Which means, now let's go back here, and if this was array.length minus something, but this is what -1, then I was trying to find out, okay, this j, okay, to which extent is going to be. So array.length -1. And now every time, instead of having -1, -2, -3, what should I do here? Minus j. And I don't need these ones anymore. Why minus j? Because the first time j is 0, so it's going to be -1. Now when j is going to be equal to 1, this becomes -1 minus 1, which is -2, and so on. And this is the bubble sort. That, you can see the advantage of the bubble sort. It's kind of easier in terms of the implementation as compared to the selection sort, but it's slower. Yes? If I put j equal 1, well, what is going to happen is that the first time I'm going to start with this I is equal to 0 until array.length -2, which means the last element is not going to be sorted. You're going to skip the last element, because what is the I? I is going to be array.length minus not 1 but 2, which means if you have your array here, you're not stopping here but stopping just here. So the last element you're going to compare is this one with this one, and then this one is going to be left out. That's what happened.
I can remove the -1 and -j and only put the -k for the I loop.
If you put it like this, then you can, because you add 1 from the left, just remove 1 from the right, and then you can just do something like this, and yes, that's the same. But since I wanted to, I did this incrementally, it makes more easy to follow up by doing this. But yes, of course, what you did is right. By putting 1 here, and then removing this -1, because I just would like to have the same number of times, and then I can just remove this -1, and that would be it. And actually it would be better. That's better than this method here. But this one is built on incremental solution of solving of the problem. Now is that okay? That's the bubble sort. The advantage of the bubble sort, as you can see, it's kind of much easy to implement as compared to the selection sort. And what I'm going to do, I'm going to call this bubble sort ascending. Now what if I'd like to do the same thing with descending? With the descending, instead of comparing this way, I'm just going to compare the other way around. Which means if this one on the left is smaller than the one on the right, then I'd like to make the swap, because I would like to have the smallest to the right. And now if I do this descending now, I run, it's going to make the smallest on the right bigger on the left. Okay, now the fun part. I would like to compare the time of these two, this bubble sort and this selection sort. So what I'm going to do, I'm going to have this selection sort just to have, I'm going to keep this the comparable thing. I'm going to just copy these and create a version with just an int, because I don't want to. So this is the one with the comparable, just going to make this one int. So now by working with int, I don't have this compared to. I'm just going to use this less than as it was, and then I'm having an int, and then it will be the same thing with this one, with descending, and this one is going to be greater than, and another int here. So now when I'm going to use this, I would like to have this selection sort ascending, selection sort descending. However, I am going to do the selection sort first, calculate the time, display it, and then copy again, do the same thing this time with the I don't need to declare them again because they're already declared, and then I'm just going to do it again this time with the bubble sort. But notice one thing, I'm not going to call the same array, because after I finish this, the array is going to be sorted already. So I don't need to, when I call the bubble sort again, it's going to be already sorted, so it doesn't make a sense. So what I'm going to do, I'm just going to say this array was sorted I'm going to say selection sort to be this time, and bubble sort to be the other time. But the bubble sort is not going to be on the same array. I'm just going to create another array which is going to be the exact copy of that one. So how can I create a copy of that array? I cannot just do this, because this is just basically going to point to the same place. So to copy an array into another array, I need a loop.
Can't I use a clone?
Can I use what?
Clone.
The clone? Well, like this one dot clone, I'm not sure though, because this is going to be an object that you cannot put into an int, and the clone needs to be implemented actually, so no. But I can use a for loop that is going to be, first of all, this needs to be the same size, so I'm going to make it new int of this array dot length. So whatever this size is going to be, I'm going to make it the same size. Then for this array2.length, or whatever, it's the same thing. Array.length, array2.length is the same value anyways. I'm going to take array of I and put it into array of I. Well, no, one of them, the first one should be 2. Now this is just creating a copy of that array into array2. Why? Because I would like to have the same type of situation for both sorting. So I have one array, and then I sort it once with the selection sort, and I calculate the time, and I'm going to sort it again, this time with array2, and then I'm going to display the sorted one. So both of these are going to be exactly the same, so just so you can see them, I just would like to display these two. So this is array, I'm just going to name it array1 to make it even clear. Array1 and array2. You had a question?
You can't catch the idea for cheat the array1 and array2. Why do you choose two different?
Because if I'm using the same array, I'm using one variable, right? So for example, I'm using array1. Now after calling selection sort, array1 is going to be sorted already. All the values are going to be from the smallest to the largest. Now if I call bubble sort, it's already sorted on the same array. If I call it again bubble sort, it's going to be already sorted, and I don't want to do that. I want the two algorithms to have the same input. The array is these values, and both of these are going to be executed one at a time on the same values, and then gives me different arrays. Of course, the arrays are going to be always sorted with the same way, but I just would like to be able to calculate the time that it took to do that for each one of them. Because if the array was already sorted, it will take obviously less time because it's already sorted. Now let's run and see. Now you see this is the initial array. After it was sorted by selection sort, it took this seconds, number of seconds, and this is with the bubble sort. As you can see, it takes more time. Obviously the result is the same, but it took more time. So because the result is the same, I'm not going to display them. I just would like to be able to display. Let's put this on this one. I don't need to. So I'm going to see them close to each other. So this is the bubble sort, this is the selection sort, and as you can see, with more runs, it's always taking less time with the selection sort than with the bubble sort. Oh, this time it took like more time. Now, what is the worst case scenario? The worst case that can happen when you're doing a bubble sort. The worst case that can happen with the bubble sort is if you always need to swap. For example, if the array was already from the largest to the smallest, and then you have to swap it again. So each one is going to be swapped. Swap. So you're swapping so many times. You're doing so many operations, and each operation is going to take some time. That is the worst case scenario. But for the selection sort, what is the worst case scenario? If it's sorted already, but I'm always doing the same thing. Even if it's sorted in the opposite direction from the largest to the smallest, and I'm trying to sort them from the smallest to the largest, what is going to happen is that if I'm looking for the maximum, but by looking for the maximum, I always have to assume the first one is the maximum and check the rest. So basically it's kind of constant the time it takes to do that. While for the bubble sort, it depends on the data. And let's just have a look at this example. See, this is this one. So how many times I'm swapping here? So I need to swap here, then swap again, because 93 is going to be bigger than 75, and swap again, and swap again, and swap, and then no swapping. This one is going to be then swapped, swapped, and swapped. But then later on, this is going to be 15. No need to swap. This one is going to be swapped, and then you have to swap again. And then, well, the number of swapping is going to, it seems like it takes less time with this bubble sort, but on general, on average, if you just look at most, probably what happens is that you'll find that the bubble sort is taking much more time. But there's some situation where you can see it's kind of, this one takes more. When that situation happens, when the bubble sort, if you see the values are already somehow almost sorted, so it takes less time to do the swapping. That's why this bubble sort takes less time. You see these are almost on the same order already. Oh, so hold on, I'm just looking at the wrong thing. This one, so there are some on the left are already there. So there's some of them are already sorted, so it's just going to do the less operations. But on average, most of the time, the selection sort is much faster. And that's why this is interesting to use it here, because now if you use this, you can use many. You see 10 arrays, if each one of these arrays with 10,000 numbers, and then if you use the bubble sort, it just on average gives you some kind of an idea. So now with the selection sort, because you have 10 arrays, so they're going to be random, so you can see that on average it's going to be kind of different timings, and generally the selection sort is going to be faster. Now I would like to stop here and let you just implement that, and I'm going to just leave you with this so you can maybe do the same calculations of the time it takes to get these sorting. And I'm just going to leave you with that, but I just would like to maybe, what I could do, I could maybe put this inside of an array that is going to just to say copy, or maybe I'm going to call it clone. How about that? Okay, I'm just going to do this, copy this, create a new method that I'm going to call private int. It's going to return an array of ints. I want it to be static, so I would like to use it. And then I'm going to call it clone array. And if you give me an array, I will clone that on this new array. I will clone that array, and then I'm going to return this new array. So I just need to do this now. Clone array with array1. So this is going to take the array1 and clone it into the array2, which basically what it does, just copy this array1 inside this new array, and then return that array. And now if I run it, it's basically the same, but the point is, the advantage is that I can show you everything in one go. Alaikum salam. Okay, your turn now.